Hey, a large part of what we're going to be doing today is just practicing SOHCAHTOA. Just practicing SOHCAHTOA. Whenever you have two sides of a right triangle, how can you find the third side? Pythagorean theorem. So number one, it wants us to find the third side, then find the six trig values. So a squared b squared equals c squared square root. It is. So now all you have to do is do your six trig functions. Sine of theta, cosine of theta, tan of theta, and then the three reciprocals. Cosecant, secant, and cotangent. So, oh, I'm sorry. Well, whatever. Yeah, you could do it like that. What is sine of theta? That's right. And what is it here? Which reduces to 3/5? What is cosine? Adjacent over hypotenuse. So 4/5. And then, yeah, if you wanted to do it just going from there by what we did yesterday, you could, but I just prefer to use the triangle. Tangent is opposite over adjacent, 3/4, and then just flip those for the next three. 5/3, 5/4, and 4/3. And it'll be the exact same way. The only thing that makes number 3 different than number 1 is when you do the Pythagorean theorem, please notice you're not looking for the hypotenuse. So you would set up the original step. Let's call this side A. You would do, oh, darn it. I'm in the forbidden part of the board, so I'll have to write it up here. It'd be a squared plus 21 squared equals 29 squared to find that third side. But other than that, everything would be the exact same. When you say solve, it means yes. Yes, you would. Questions about this first slide? This is pretty much what we're doing all day today. So if there's no questions, that's a good sign. All right, same thing. This is exactly what we just did in the DOM. Only difference is, instead of writing theta, they gave you an angle. But here are some triangles to use. Cosine of 30, adjacent over hypotenuse, radical 3 over 2. Of course, you could look at your unit circle, but these triangles are up here. It's up to you. I don't really care how you do it. Yeah, mostly. I tried to make it a not-so-bad lesson for the midterm. Secant 45. Again, you could do it one of two ways. Secant's the flip of what? Cosine. What is cosine 45? Hannah, what's cosine 45? I will, hold on. No. That's right. Flip it. Good. So radical 2 over 1. Ah! Dadgummit. Whoa, we were doing secant, right? Secant 45. Braden. Secant 45 is opposite of cosine. Cosine would be 1 over radical 2, but you don't have to rationalize it because we're just flipping it. So that would be radical 2 over 1. Radical 2 over, which is just radical, okay, it's fighting me, but it's radical 2 over 1. You just find cosine and flip it. Let's look at 19. That looks to be the trickiest one. 19. Pi over 3. Pi over 3 is the same as what angle? 60. Tangent of 60. Opposite over adjacent is radical 3. 2 times radical 3. So we're going to do this little piece at a time. So that's 2 times radical 3. Cosine pi over 4. Pi over 4 is 45, right? Cosine is adjacent over hypotenuse. So, times tangent pi over 6. Pi over 6. Tangent opposite over adjacent. That's 1 over radical 3. So we're multiplying this times that. Or no, we're adding this plus that. Okay, I punched that in the calculator. Tangent's opposite over adjacent. Yeah. Sorry? Yeah. But I would still punch it. You could leave it like that, I guess. That's kind of ugly. What? No, I got tangent pi over 3 was opposite over adjacent, which is pi over 3. And then I did 2 times that. The fact that these have, yeah, I did tangent and then I multiplied by the 2. Questions about how to do any one of them on this screen? Yeah, it's going to be decimal or something, I believe. Yeah. Either way you want to do it, fine with you. Any questions about this slide? Moving on. Okay, I'm not actually going to quiz you on this. This is not included in your homework. But there's just one thing I wanted you to notice. Going back to the DOM, these are considered cofunctions. These are cofunctions. Sine of any angle is going to be equal to cosine of its complementary angle. As you can see here, sine of, I think this was 60 degrees, and then cosine of 30 were the same thing. Every function in trig has a cofunction, something that is equal to the exact same thing. And you would know that. I mean, if I were to give you a triangle or a list of triangles and say, find all 6 trig values for both angles, you'd see that there were pairs all over the place. So, although I'm not going to quiz you on this, I just want you to know, all this means is like sine of 7, its cofunction would be cosine of 83. If you were to draw a triangle, 7 degrees, 83 degrees, sine of 7 is this side over this side. Cosine of this one is still those 2 sides. So that's all this is referring to. That would be cosine 83, secant 65, cotangent 8 pi over 9, etc. You don't have to know all that stuff. I'm just, that's what it's referring to. So when you see it in your book, don't think it's some horribly complicated thing that you're going to need to know. All right, back to the more relevant stuff. We're now going to use trig to solve these triangles. All of these problems are going to work the same way. First thing you have to find an angle to start with. So 29, what's the obvious angle choice to start with? 37. Use the one it gives you. That's right. From 37, which 2 sides, and don't tell me A and 250, obviously. Which 2 sides, opposite, adjacent, hypotenuse-wise, are we working with from 37? That's the... There you go. Opposite and adjacent. That's right. Which trig function uses those? Tangent. You're getting those 2 mixed up. So tangent of our angle equals opposite over adjacent. How do I solve for A? Multiply, yeah. Now, please notice, is that angle a radian or a degree? So make sure you're in degree mode. Get out your calculator. Make sure your mode is in degrees. Then just punch it in. 250 times tan 37 equals 188.4. And that's what A would be, 188.4 degrees. It's all about what angle you're using. If it's a degree given to you, you're going to use degrees. If it's a radian, if this was pi over 4 or something, you'd use a radian. Now, I will say this. I know people like to do these problems at different rates and plug them in different ways. Please notice, you see how I kind of did all the math at the one step here at the end? Please don't, I mean, it's not a huge deal, but don't do tan 37 and say that's 0.6 and a bunch of decimals. So like, that's approximately 0.62. And then take that and multiply by 250, because that's, when you round off part of your decimal and then multiply it by something, you're multiplying everything that you've rounded. So if you round off 1 and then multiply by 20, now your answer drops by 20. So whenever you have trig in a problem, don't actually put it in until you're finished, until you're ready to put it in all at once into your calculator. Let me show you what I'm talking about. So the answer to this one is what? 188.388? Let's say I had done this in multiple steps. Tan 37. That's approximately 0.75. So I'm going to take 0.75 times 250, and my answers are different by about 1.2. And that's not a big deal, but sometimes you'll be multiplying it by thousands, and the answers will be more and more different. So don't round off trig here. Either take it exactly as it is or just plug it in all at once. Well, your answers are going to be a little off. Does that make sense? Raise your hand if that was total grief. No grief. Okay. So let's just keep going. 31. Which angle are we going to use? 34. Yeah, it's usually going to be pretty obvious. Which two sides are we using from 34? We don't know the opposite. We're looking for the adjacent. We've got the hypotenuse, and that is which trig function? Cosine. Cosine 34 equals adjacent over hypotenuse, multiply, and just plug it in. 220 times cosine 34 and you're done. We'll set up the 33. Obviously we're going to go from the only angle it provided. Which two sides do we have to work with? Opposite and hypotenuse, which is sine opposite over hypotenuse. Now, please notice this. Whenever your variable's in the denominator, essentially these two pieces are just going to switch places because you're going to multiply by c and then divide by sine 23. So this problem turns into c equals 16 over sine 23. No, that's a. I just can't write. It was 188 point something. Let's see. So 16 divided by, please stop, sine 23, 40.95. What's it say? Nearest whole number. So 41. Directions it says nearest whole number. So 41. Questions about that? That is pretty much everything else that we're doing. There may be one or two other little things in there, but not many. Oh, good. Well, let's just keep marching. Inverse trig. So we know if sine of theta equals 3/5, we could draw a nice triangle and put 3 here and 5 here. But another thing you can do is use inverse trig to solve these. So if sine of theta equals a decimal, you can find out what theta is simply by putting it in your calculator. And I said yesterday the reciprocals were not the same as the inverses. So to solve this one, you would take sine inverse of both sides. Sine inverse of 0.2974 is approximately 17 degrees. Yeah, that's all you have to do. Now notice on 39 and 41 it wants it in radians. Not a big deal, just switch to radians. Enter. And you don't have to put it in pi or anything. Just second cosine 0.4112. So that'd be approximately 3 decimal places, 1.147 radians. And that's it. I'm glad you think so. Questions about that slide? Great. This seems like kind of a silly thing for them to throw in here, but they're just showing you can use trig in functions. You evaluate it just like you would any other function. Plug in pi over 6 for every theta in the problem. So that would be 2 times cosine pi over 6 minus cosine 2 times pi over 6, which is, yeah, you absolutely could. Or you could say, what is cosine pi over 6? On your unit circle, what's cosine pi over 6? No, I mean, what's its value? Square root of 3 over 2. Sounds so interested, Allie. What is cosine of, what is this, pi over 3? What's cosine pi over 3? One and a half. You have unit circles, people. So anyway, cancel, cancel. And that's just, okay, this is fighting me. But you can see that's just going to be radical 3 minus 1/2. You can find it as a decimal cube 1. Just plug it in. Just plug it in your stinking calculator. Alright. Fun stuff. Yes. Here's the thing. When they give you a picture, don't bother with the word problem. That's just going to confuse you, if anything. What angle are we going to go from? What two sides Don't say question mark in 630. What two sides are we working with?
Adjacent and opposite.
Which is tangent. So tangent of our angle equals opposite over adjacent and solve. And I know you can finish it from here. Multiply by 630, calculator bill. I'm trying to find one where you have to find, here we go. Now, this one, this is why we did the inverse trig. We're looking for an angle. So from that angle theta, which two sides are we given? Don't you dare. Very good. Which is which function? Tangent. So tangent of theta equals opposite over adjacent. Now, this is why we did the inverse trig. If you're looking for an angle, you'll use inverse trig. So that would be tan inverse of 125 over 172 will give you your angle. Bang. Oh, I'm still in ratings. Try this again. Oh, dang it. Okay, 36 degrees. Much prettier. Questions about how we set that up? Why we punched in the calculator like that? Any questions like that? You got this? All right. Fine. There you go.